I'm Shubham Chaudhary from Electricity, and my team consists of myself, Ayush Tandon, Ethan Cruz, and Peyton McCutcheon. Our aim is to identify objects using machine learning. Previously, we showed you how we did line of sight detection using USRPs and antennas, but this time we have taken the project a step further and we've added two objects, and we have collected data about those two objects using the USRP and antennas, which we have then fed into our machine learning.
Whenever.
So this is our lab setup for the new experiment. It's very similar to the last one, just that we added objects in the middle. Our first object is a wet caution sign. Second is a chair. So here we have three USRPs, two working as a receiver, one as a sink. This is our clock, and down below here we have two nanos, which are like mini PCs, with a router which is connected to both the nanos. If we move along here, we have our transmitter side with one USRP connected to the Pi being powered up. Yeah, that's it.
So, as Shubham was saying, once we finally collect our data for the two different objects, we put it into this Jupyter file that we've shown previously in our other videos. But most importantly, we're only focused on one of the channels for our data collection, and that comes down to these few graphs right here. Once we select the channel that we would like, we feed that into a CSV where we save it and we run that. It depends, but for this project we did 100 samples for each item. But obviously, to increase the training accuracy, we would also increase the number of samples that we have. Finally, so once that's done, we get a large data set like this that's very messy at the moment. Obviously, we can't make much information out of this, but then we send this off over to Peyton for our machine learning aspect and hopefully make sense of the information we have here.
I'm going to take you guys through the machine learning aspect of the project really quickly. Okay, so in this first set here, we have a perceptron, logistic regression, SVC, and decision trees. As you can see, our accuracies are generally pretty high out of this entire thing, with the lowest one being the 93 from the decision trees. And as for our neural network, you can see here 96, which both are well over our accuracies that we wanted and were shooting for earlier. Now, as far as the data set goes, the first 64 entries, or first 64 columns of each one of the samples, is the data we have collected and outputted from Jupyter for multiple runs. The final column is the class number, and in total we're going to have two classes, 1 and 0, also known for the different objects. Future work in this area can mainly be done on the fronts of around the corner / non-line of sight testing. Because of our time constraints, we were not able to do that. The main difficulties we faced in this project were getting the code to run with our setup. That is the hardest part, hands down, and that's what took us the most time, was debugging and making sure it could actually collect data and work with the equipment. Once you get that part, the rest falls into place. So this ties back into the future work. The hardest part for future work is getting any non-line of sight equipment that we're not already working with in our line of sight tests, getting the code to function